So here's another example. And this one, I've completely factored the numerator and the denominator for you. That way, you don't have to do that. So I want to know what I can figure out about this function. Something I can find is the domain. Let's talk about the vertical asymptotes and the horizontal asymptotes. Those are the pieces that I really need to find. Okay, so the domain, where do we have issues in the domain? Notice that in the bottom, we have 3 factors. Here, if we set 3x equal to 0, we get x is 0. If we set x minus 1 to 0, we get x is 1. And x minus 2 equal to 0, we get x is 2. So these are the 3 numbers we cannot beat, 0, 1, and 2, which tells us that our domain looks like this. Remember, put unions wherever you have to take a number out. Don't forget the numbers between 0 and 1, and also from 1 to 2. Now, this is the part that's going to be a little different from the other ones we've seen. To find the vertical asymptotes, we simplify this function as much as we can. Notice that in this function, I had an x minus 1 and an x minus 1, so I'm going to cancel those out. Now, we do have to take that point out of the domain, okay, in this unsimplified function, because this is the original function. What I'm doing is I'm simplifying it, so I'm changing it just a little bit. So I'm crossing that out. My vertical asymptotes are going to correspond to what's left. So we're going to have a vertical asymptote at 0 and at 2. Okay? The next thing is I want to find my horizontal asymptotes. To find my horizontal asymptotes, what I need to do is I need to figure out the degree of the numerator and the degree of the denominator. Okay. I'm going to erase this piece. You could mark it out, it's fine if you want to find the degree that way, but I'm going to keep it all like originally how it was. Okay, so if I was to multiply all of this out, what would I get? What would be the leading term? Well, I would have this x, I'd have this x, and I'd have this 5x. I would get a 5x, 1, 2, 3 cubed, and then I'd get some other stuff. But that would be the leading term, the part with the highest degree. Now looking on the bottom, if I multiplied this thing out, I get 3x times an x times an x. I get a 3x cubed and some other stuff. But the highest power would be 3. Notice that the degree of the numerator and the denominator are the same. So when this happens, our horizontal asymptote is y is equal to, all we have to do is take the ratio of the leading coefficients. So it's y is equal to 5 over 3. Okay. What I'm going to do is I'm just going to give us an idea of what this looks like. We're going to have a vertical asymptote at 0, also at 2. 5 over 3, that's 1 and 2/3. So if this is 1 and this is 2, we're going to have something here. Now, other than that, we really, at this moment, can't figure too much out about the graph, but we should have something like this. Okay, so let's graph that. So let's switch our screen. So this was the last graph. Let me get rid of that. So f of x is equal to, let me write all of this stuff down. It was, oh, here it is. X plus 2, x minus 1, 5x minus 1 over 3x, x minus 1, x minus 2. Let's see if we get some asymptotes where we expected it. We expected an asymptote, get rid of this, at 0, which this kind of looks like an asymptote, like what we were expecting right here. Then we have something right here that looks like an asymptote. Let's click on it, the graph, and see, oh, we're approaching, the y values are approaching 1 and 2/3. You can see that we get past 1.5. Same thing here, we're going towards 1 2/3. And then we had another asymptote at 2. So if I click here, you can see that as we get closer and closer to 2 for the x value, the y values are going up. And the same thing here. Closer and closer to 2, the y values are going down towards -infinity. Interesting. So one thing that was different was we had to take out the number 1 from the domain. And that didn't correspond to a vertical asymptote, and you can see that here. If I'm 1, the x value, you see I don't have a straight line right around here. But if I zoomed in, what you would see, you zoomed in a whole lot. Now, this is a graphing calculator, so you won't be able to see it very well. If I get really close to 1, which is right around here, what's going to happen is I'm going to have a hole. Oh, there it was. You see? Undefined. There. I've got a hole there. I have a part missing from the graph. And we'll learn how to graph that later. But that's something I want to bring your attention to. Whenever you get rid of something from the numerator and the denominator, it becomes a hole in the graph. Okay, let's move on. There are other types of asymptotes. There's something that's called an oblique asymptote. That's the asymptote we're going to learn about. So I'm going to put that here. Oblique asymptote. And it's interesting that you can have vertical asymptotes and horizontal asymptotes. You can have vertical asymptotes and an oblique asymptote, but you can't have a horizontal asymptote and an oblique asymptote. You're always going to have one horizontal asymptote or one oblique asymptote, or no horizontal asymptotes or oblique asymptotes. So we're going to learn about this and how we can find it. So an oblique asymptote is an asymptote that's a line. That's not a horizontal line. So an oblique asymptote is an asymptote that's a slanted line. So what I mean by that is the slope is not equal to 0, or the slope is not equal to being undefined. So it's not going to be, so I'm going to put no here. It's not going to be a line like this or a line like this, because these are vertical asymptotes and these are horizontal asymptotes. The kind of line you're going to see is something like this. Just like the equation y is equal to ax plus b. Here a is just not 0 or undefined. So it also could look like this, just some kind of slanted line. And this happens when the degree of the numerator is 1 power bigger than the degree of the denominator. So let me write that down. We get oblique asymptotes when the degree of the numerator is 1 more than the degree of the denominator. This has to be exactly 1 more. Now, if it's more than 1, so if the degree of the numerator is more than 1 unit above the degree of the denominator, then you're not going to have a horizontal asymptote or an oblique asymptote. Your function is going to look like a particular power function. And we'll see that in a few minutes, but I want to just focus on this. So how we're going to find this oblique asymptote is we're going to use long division. So the best way for me to show you this is to actually do a problem.